Jai Janendra, Namaste, welcome to my channel. Today we are going to solve 35th question of the problem solving series, which is based on binary search. This is the 5th question of the binary search. This question has been asked in Adobe, Google, Microsoft and multiple companies, and the difficulty level for this question is medium. So we need to find the pick element in array. What is a pick element? So in this example you can see that this is not a sorted array. We know that we can use it apply binary search in a sorted array or rotated sorted array, but this is not neither sorted nor neither rotated. This is a normal array. We need to find the pick element. Now what is pick element? A pick element is an element which is greater than both its neighbors. So here for example 3 is greater than 2 and 3 is greater than 1. So this is the pick element here. And in this one you can see 2 is greater than 1, 2 is greater than 1. This is the pick element. Also 6 is a pick element here because it is greater than 4 and 5. So pick element is an element which is greater than its predecessor and its successor. Just the neighbor part. Okay. So now how do we solve this? Normally if we need to solve it, we just need to compare when we will traverse the array and we will compare whether that element is greater than its predecessor or successor or not. Now if we travel, for example this one, the first element, does this has any previous element? No, it doesn't have previous element. So if this is greater than the next element, then automatically it is a pick element. And there could be multiple pick element in an array. For example here. So we can either return 6 or 2. Anything. 2 answers. Either of a pick element we need to return. So in this case, if this was 4, then our answer would have been 4. Also, I think we need to return the index of the pick element. So the index is actually 2. So we will be returning 2 as per the question in the description in LeetCode. And here the pick element is 1, 2, 3, 4, 5, 6. So our answer would be actually 1 or 5. Right? Index. Okay, now how do we solve this? So we found out that if the first element is greater than the next element, then it will be our pick index because it doesn't have a predecessor. Similarly, for last element, if it is greater than the previous element, then it is a pick element because we don't have the next element. The last element is the last, we don't have any next element to the last element. So we have got two conditions. So we have edge cases, right? What are the edge cases? If there is only one element, then we don't have anything to compare. So if n equal to 1, so what is n? N is say array dot size, the size of the array. Right? If n is equal to 1, then what would be our answer? The first element itself. So we return its index, return 0. Right? If A0, array 0 is greater than array 1, then what will happen? We will return 0. Right? Else, if array of n minus 1 is greater than array of n minus 2, then what will return? We will return n minus 1. Right? Now, these are our edge cases. Now, if we don't have any edge cases, normally we would traverse the array and we will find out, right, in order of n, right? Normal time complexity order of n. But can we use our binary search to solve this problem? Yes, we can, and the time complexity would be order of log n. Now, how do we solve this binary search? So we have seen there are two cases, right? Either the first element is itself a pick element. If I make a graph, the first element is itself a pick element and then it is greater than the second element and then whatever happens. Or it could be that anything happens and the last element is the pick element. And the third case is that there are multiple pick elements, we need to find one pick element. So to find one pick element, its left part will always be less than this, right? And the right part will also be less than this, okay? But this part would be sorted, isn't it? Or this part would be in the reverse order, right? So this one part would be sorted. So if we can figure out we apply a binary search over this, and we see that if the middle element, whatever is the middle element, for example here 0 plus 3 by 2, 1.5, 1, this is our middle element, and if this middle element is greater than its previous element and it is greater than the next element as well, then this is our index. But in this case 2 and 3, it is not. That means now what do we do? This is not greater than the previous and this is not greater than the next. Now we need to eliminate first half. How do we eliminate the first half? What we can do here, this mid element is 2 and this is actually greater than the previous element, but it is smaller than this. That means here the graph is increasing. Okay, so it could be that in other place we will have our answer. Here we won't have our answer, right? Because this is increasing, I believe. So in this place we could have our answer. So we'll eliminate this part and we'll search over here because this is shorted part. Okay. So what we will do now, we'll make our low as mid plus 1, right? And high as, so low will become mid plus 1. So what would be the value of low? Low would become 3 and high would become n minus 1. So now 2 plus 3 by 2, 5 by 2, 2.5 is 2. So now 3. Now 3 we will check this mid's previous value. It's greater than 2 and it is less than 1 and it is greater than the next element as well. So we have got the value here. The mid value will become 2 and we will return our answer. So in this way we can apply binary search. After the edge case, what we do? Int low is equal to 1, high equal to n minus 1, right? And while low less than high, what we do? Mid is equal to low plus high by 2. If array of mid greater than array of mid minus 1 and array of mid greater than array of mid plus 1, we have our index, we will return mid. Okay, else if this is not the condition, only this condition is true. Array of mid minus 1 is actually less than array of mid. That means this part could be sorted part, or we don't have our answer over here, we will search in this part. Okay, because this part is sorted, right? We will believe that this is sorted, so we will make our low as mid plus 1. Else, if that is not the case, we will get it somewhere that is not the case, then we will go to the right part, right? Left part. If this is not true, then our high will become mid minus, high will be equal to mid minus 1. Okay, and in one case, this will come over here, and then we will get our answer and we will return this mid. Okay. Yeah, so we'll have our answer. This will, if there is a peak element, that this will be returned, or we'll return mid over here, whatever the mid value is there. Okay. So I think the explanation is clear. The time complexity is order of log n. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section.
Here is the code walkthrough of the 35th question, finding the peak element. You can see in the lead code platform it's Medium, and the companies are these companies where this question has been asked. So we directly move to the code here. So we have the edge cases covered here, all the 3 edge cases, and then you can see this is the binary search implementation. We have added these conditions and I've already discussed everything. So I'll just directly submit this code. So this code has worked. You can check your answer with this code and yeah, can verify the solution. I hope the explanation has been clear in the code explanation part of the video, and I'll see you in the next video where I'll be explaining the 36th question of the problem solving series. Cheers.